Well, this sure is a beautiful looking battery from Orient Power. This is their new wall mountable battery. It is 100 amp hours, 51.2 volts, or 5.12 kilowatt hours. In this video, we'll take it apart. We'll do a capacity test and a load test. And you'll see how I got it up here on the wall. This beautiful new battery comes with a few accessories in the box. So real quick, we have this massive mounting bracket. I mean, this is made out of thicker steel than I would have expected. Look at that. And it has all these 8 different spots for you to screw it to the wall. And then it comes with these anchor bolts. And so these are designed to go into a drilled hole in masonry or concrete. And then when you tighten them down, they expand. So they're expansion anchors. It comes with some rubber caps for these terminals and it comes with the bolts that have a flat washer and a lock washer on them. And those are for each of these terminals. We've got our instruction manual, and there's actually a lot of good detail in here. A communication wire and an inspection report. So all these things come in the box. That worked great. All right. Well, with the lid supported on a cardboard box, you can see there's a nice long cable here, which is great. A lot of manufacturers would make that really short and tough to get the lid off. We're looking inside. You can see the jumpers between the 2 posts. We have our on-off switch. We've got our BMS in here. It's a nice looking BMS. Another heat sink on the back side of the BMS. And this BMS looks identical to the Jacopher server rack batteries, as well as the circuit breaker that they're using and the terminals they're using. So everything looks very similar. This just has a longer cable coming off here. We still have 2 positive wires and 2 negative wires. I think they did a very clean job installing these wires onto the jumpers. I've taken apart the other Jacopher server rack battery, and these screws were twisted so far that there was a kink in the wire. And now we don't have that. So it looks like they've done a nicer job. Let me give these a yank here. Good, they're not turning. Yep, good. So they're all on there nice and tight. And it looks like we've got our cells underneath another big steel cover. See, one of the concerns I had was this sheet metal top is a little bit thinner steel than the sides are made out of. And I was worried that if you pressed down, would you hit the cells? But it looks like they're protecting the cells with another piece of steel, so that's very nice. Let's take this cover off and take a look at the cells. All right, excellent. So this is a 16S lithium iron phosphate. We've got these rails going down the middle, which are helping to hold the cells in place so they don't fall out. So these are steel U-shaped channels. And it looks like they're screwed on over here. And there's probably a piece of foam. Yeah, I can see a piece of foam down in there between the top of the cell and the steel. So that's good. So right now I've got a plastic ruler sitting on the steel, and it looks like it's hitting the nuts, unfortunately. Yeah. Darn. So it would have been nice, in my opinion, if this steel was just a little bit taller, and that way, even if something went terribly wrong and you had a lot of weight right on this steel and you crushed it, this steel rail would still help keep this steel from making contact. Now the good news is that they have this piece of insulating, feels like a closed cell foam on here. So that's one one minor thing. I don't think the overall quality here is bad. It's just something I'm noticing that they could have improved if this steel channel was just made slightly taller than these nuts. Yeah, so the foam separators are the one thing that I would draw into question. They have foam all the way around the sides. So all the way around the sides, they got foam. They've got foam in between each cell this way, but down the middle, I don't see a piece of foam. And so I was taking this scrap piece of plastic here, or it's a scrap piece of paper, but it's just got a plastic facing on it. And so if I can slip that all the way down in between the cells, and now I'll hold it here with my thumb, you can see I was all the way down the side. So there's no hidden separator running down the middle. So it begs the question, if it's important to have a separator around the sides and important to have a separator here between the cells, why wouldn't there also be a separator at this end? So the temperature sensor down there. And it looks like, just like on the other Jacopher, we've got 4 temperature sensors on the cells, and then we're going to have some built into the PCB. So the main negative and main positive have a double wire coming off the single lug. They usually do that for flexibility. And then the positive goes into the circuit breaker. And then it comes out the circuit breaker and comes up to the posts. So it looks like from here they go to the BMS, and then they come out the BMS somewhere on the bottom for that pair, where it then loops back up over here. So all that looks fine. And there's a ton of distance here between the wall and the cells. So you could, it looks like this thing could really take a beating. It looks like it's built tough all the way around. Those cells are really protected. Overall, I think the build quality is really good. It's just nitpicking that I would have preferred to see these steel channels here a little bit taller than the nuts. But, you know, they've got heat sinks on the MOSFETs. The wire looks good. I haven't found any loose connections that I've been going through. So overall, I like the quality. I like the build. It's not a bad setup. And the other thing, let's see here. Yeah, all of these, there's another piece of steel right here, and all these voltage sense wires are all zip tied in place. It looks like it's built well. Now, I don't see any reason why this has to sit straight up and down vertically on the wall with this downward. Everything in here looks like it's secured so well that you could probably orient this on its side, and it doesn't look like anything bad would happen. So we will install it according to the manual, but I'm not seeing any reason why you couldn't just use it sitting here flat without an issue. Maybe they're just concerned that if it was sitting flat and somebody stacked something on top. That might be their reasoning, but really, I mean, the whole build quality here looks great. Well, the Powerwall is now at 100% state of charge. And this is no longer blinking, and it's a solid green light. We're all ready for the discharge test. I've got the space heater, which is this typical load I use, this old inverter, this meter that I built in a previous video, and the brand new Orient Power Powerwall. Got our circuit breaker on. Let's turn on the BMS. And right there, we can see that we're at 100%. That's what we want. All right, so let's get the party started. Here we are. And let's see what we're doing here. So 27.8 amps. So this should take about 3.5 hours to discharge. And we'll have our kilowatt hours here and our amp hours up there. Right now this says 28.39 amps. All right, we'll catch back in a few hours. Anyways, the capacity test is done, and we just missed our mark just a little bit. 5.11 kilowatt hours, 99.6 amp hours. So we're very close. This is probably within the margin of error for the accuracy of my meter, but it would have been nice to get past that. Now for this mounting plate, common framing in the United States is 16 inches on center. That's even why we have 16 marked out in red on our measuring tapes. But over here, we can see that we've got this lined up with the center of the hole, and over here it looks about 13.5 inches. So this is not going to hit 2 studs, but I will try to line up at least one set of holes with the stud, and the other ones will go into the 3/4 inch OSB that I have for the backing. I tipped the battery on the side, and this is how the mounting bracket is going to fit in. It all looks very beefy, but now I can measure down, and it looks like 8 inches down from the top of the battery is where the first screws are going to go. I'm going to drill out for at least one really large structural screw. I'm going to fill in the rest of the holes with some 2-inch cabinet screws. They'll go through the cement board and secure to the OSB. We've got the one really large structural screw there, and the rest are cabinet screws. And this one I actually put to the bottom of the hole to prevent if you're pulling upward and things get caught, to not move the bracket around. So now it is all secure. There's no way that's going anywhere. I think that's even more fasteners than I have for those inverters. So it's definitely not moving. So if we did our math correctly, then the top of the battery should line up with the top of the grow-watt inverters. Well, this battery is really heavy. It is hard to get up here. But the good news is that the hooks on the mounting bracket are really large. So it was, you didn't have to be exactly dead on with where you landed this. It kind of found its own. So that's good. Well, I just wired in this Orient Power Powerwall. I've got these big giant lugs on here. They're bigger than the terminals. But these are 4-aught wires going down to my bus bars and then feed these 2 inverters. So we're about to turn this on. Let's see if it can handle it. Handle the capacitors inside here. So let's crank it on. All right, it looks like it did it. Nice. Did not fail. That's awesome. So these are getting pre-charge resistors built into them these days, and that's great. So we can, that turned on. Good. Now I think I have this at 100% because we're gonna do a load test. Well, I turned on this old cell phone that has a Victron app on it. The app connects through Bluetooth to read the shunt, which is inside here. That way we don't have to keep pressing the screen to turn on. So first, let's see if we can turn on the dryer. This is just one battery powering both inverters. So if we turn on the dryer, all right, so let's kick this on. Go to time dry. So we're on high heat. Let's turn it on. Nope, it didn't do it. So this shut off. So we have an alarm. So it could not start the dryer. That happened really quick. Overcurrent protection, OCP. All right, well, let's see what it takes to restart this. So if we press the power button, shut it off. We turn it right back on. Will it start up? These haven't started inverting yet. So we've got 2.88 amps. I'm about to go turn on the dryer and let's see it shut off. All right, there it goes, off again. All right, well, we started this thing back up. We're going to let these start inverting. So we know for sure that this cannot start a dryer. So now let's bring these back online. And let's try starting the water heater. So this is a 4,500 watt water heater. 94 amps, and it can do it. Well, that's excellent. Now let's kick on a little bit more. So that's running. I'm going to go grab a space heater. 94 amps. Let's see if we can start this little heater. And no problem, 97, 98. All right, so let's turn this off. Let's try starting this in low mode. Oh, all right, so that shut off faster than I could click this button over to low mode. So let's go ahead and shut these off. Go. Bring things back online. This is hard on these inverters. I hope I don't burn them out doing this test for everyone. It's not the battery's fault. We're just finding the limitations of the battery. But it is hard on the inverters to keep doing this, losing the DC voltage. And by the way, we have solar turned off, so no solar input to assist. All right. Now we'll go down here. All right, so now we'll try this on low. There we are. Okay, so we got 17 amps. Now I'm gonna turn on the water heater over here, but I'll keep the phone watching. And once again, turned off really quick. Well, we're definitely finding out that this battery does not do a surge well. So the BMS really is limiting it to 100 amps. We're jumping up to 111 amps just for less than a second, and it shuts off. So it's not even 1 full second. But I mean, that's okay. It's, you know, part of the deal. We're just finding its limitation. I wanted to see if it had any surge ability. It doesn't look like it does. So if you're going to buy this battery, just keep in mind that it's limited to that 100 amps. Now, it probably can do the 100 amps fine, which is what we're about to run our test on. We're going to run 100 amps for an hour and see if it works. Oh, hey, it looks like it automatically restarted itself. I didn't press the button that time around. Well, that's good news. I just finished running this battery for an hour around 93, 94 amps, and it did not shut off. In fact, this inverter has shut off due to low voltage, and this one is trying to keep up right now. It's about to shut off. So it's a success. It can do the 100 amps. It just can't go over it. Not even for a second. But that's, you know, what we expect of these, and I'd say it was a success. Now, I did overload this battery a couple of times on purpose. I wanted to see where its limits were, and I found that it showed 111 amps on here just for a brief second when I would do a couple of things with heaters or trying to start my dryer, and it was a fraction of a second that it was up on the screen, and then the BMS faulted and shut off. So this really is not made for surges. It can do its 100 amp rating continuously, which is great. Just keep in mind that it doesn't do surges well. This will be applicable not really with the grow watt style inverters, but if you have a different style inverter that has a major transformer built in, some of those really heavy transformer based inverters, they can do surges for say 30 minutes. You would need to have enough of these batteries to handle that surge capacity. One battery won't handle a surge capacity. So just keep that in mind depending on your system. But that would be a bad scenario to try to push these to their absolute limit anyways. always try to keep your batteries to a ½ C rate, which means try to size it so that you never push the battery more than, in this case, 50 amps, because this is a 100 amp hour battery. So if you keep all of its loads down to 50 amps or less, then all of your equipment will last longer and run happily. If you're looking for a really beautiful battery that can wall mount and line right up with the rest of your equipment to keep your floor free of large racks, then this is a great option for you. I think you're paying a little bit of a premium for the ability to have this up on the wall, but not much. I like the package. I like how they put it together. Please use the links in the description below. Those are affiliate links and they really do help out the channel. And there is a coupon code if you would like to get a discount on this thing. So thank you everybody so much for watching. If you enjoy these videos, please like, subscribe, comment, and share.